Okay, so now we are on the hour when I should start. Sorry for the break before, there was a person missing, but I'm going to use my time. I think it's important to give the all competence and that you share this on these occasions like Chillventa. Yes, so I'm going to talk about sustainable heat exchanger technology for medium and large heat pumps. My name is Tommy Angbak. I'm from the company Alfa Laval. We are a heat transfer specialist and producing heat exchangers for heat pumps. Investing in a heat pump is a great decision for a sustainable society. This story is about how we as a heat transfer specialist can focus to help maximize the impact of the investment you make. We have a very, very strong sustainability focus in Alfa Laval. We ourselves, in our operations, has a net zero target for 2030. But most important is we work with our partners, suppliers, customers to develop energy efficient solutions utilizing clean energy, and of course also have a good circularity in the supply on the products. So large heat pump opportunities in a sustainable society or city there are many. We can see industries that would find waste heat and use that to produce higher value heat within industry. We have natural sources like rivers, lakes, seawater, where we can take heat as a source and produce heat for the factories or for the cities. And also, for example, data center is a big energy source for waste heat, where we can have heat pumps to produce heat and heat cities and facilities. Also within the district heating network, if you can recover low value heat and produce higher heat again, regenerate heat. There are some parameters which you know that if you want to make a heat pump efficient is you have a source, some kind of heat that you want to use, and how can you get the best efficiency out of that? So you should question your temperatures. What do you really need as a sink source? The higher the lift, the less the efficiency will be of the heat pump. And above 100 degrees, there are fewer options being developed and becoming more efficient. But if you go below 100 degrees in sink temperature, you can have a good COP of 3 to 6 something. And then refrigerant type, if you, depending on the conditions, there are several options. By selecting, for example, natural refrigerant, like ammonia, instead of a synthetic refrigerant like R134A, you can increase efficiency by sometimes 30%. And the natural refrigerants are also sustainable ecologically. So, and then of course the system design and the components included. There are compressors, and I'm coming to the heat exchangers, so we'll talk more about that. Pumps, valves, regulations and other things are of course important stuff. In a large heat pump there are many positions of heat exchangers which I'm working with and we are working with. There are evaporators, obviously condensers, subcoolers, the superheaters, oil coolers, recuperator. And sometimes combined into one heat exchanger we can make things very compact, very efficient, all of these positions. Our Alfa Laval is supplying heat exchanger, and we always want to look at sustainability. But the parameters is not only the heat exchanger itself, it's to be designed for efficiency, supporting the high COP, designed for safe use with more and more toxic, or say more flammable refrigerants are coming, synthetic and natural, and designed for compactness, and assure that you have a long operational lifetime, and that we reduce carbon footprint of the components that are included. I'm going to show you some examples here. I'm going to follow the semi-welded plate heat exchanger, which is this one, where we are developing continuously new products to fit for the duties and the challenges in heat pumps. We have, for example, here is the ammonia case where we have a new condenser that we are launching this exhibition, T21 BWFX. It's 15 megawatt plus ammonia condenser. We also have just developed, launching also a big evaporator, T25 MV FD. But that means that we have quite a big range of products and it's going to be evolving and for different refrigerants. So how are we working with efficiency on these heat exchangers? With plate heat exchangers, there is a possibility to increase the efficiency. And the COP, is how much energy we produce heating over the input of power to our system. And if we can increase the evaporation temperature by 1 K, we can improve efficiency by sometimes between 3 and 6%. And if we can lower the condensing temperature, we can increase efficiency by up to 3%. And as you can see here, we have solutions with condensers where we can, in one heat exchanger, heat the secondary side above the condensing temperature using the superheat in a combined solution. But that are things that we are doing to improve efficiency and compactness. The semi-welded heat exchanger is made up of cassettes that are sealed with, on the low pressure side with a field gasket, and on the high pressure side we have welds plus rings. These gaskets and seals we can select for the different media we have, depending on the refrigerant, is it ammonia, hydrocarbon, CO2, or HFO, plus the oil, and depending, of course, for the other side on the field, on the source media we have temperatures. And the gaskets allows the units to be open, extended, so it's only opportunity. And especially when you have a dirty source media, it's of course very good. And then an opening could be every 8 to 10 years to clean the unit, depending on how you have auxiliary equipment. I will come to that. An extended 5 years warranty is included with a new supply of these heat exchangers for heat pumps. These gaskets also mean that we have a superior resistance to fatigue issues. The gaskets absorbs metal plate and frame movements. Wow. So we will not have any fatigue risk. And if we have any seal failures, it's always external leakage and we are not mixing medias, which is fatal. So there's built-in safety, but also size of this compared to shell and tube heat exchangers, for example. We will reduce the volume of refrigerant, which reduces the cost of refrigerant. But if you have natural refrigerants, they are not so costly, but it's good to reduce because you can get under various regulatory certificates and safety inspections in the various markets, depending on the rules. They are also the weight is much lower, and you can have a less structure and floor construction, and it requires also floor space to a minimum, which means you can have a smaller building investment. So there are many advantages. If you have fluids that are dirty or fouling, in the plate heat exchanger you have a high turbulent flow, and what we call, when we get that, we get a high wall shear stress, so the units are in fact cleaning themselves. And if we have a good distribution of the fluid over the plate, we can keep the plate normally clean. But if you then have very much fouling sea or river water with dirt and big particles we would suggest having a back filter, a strainer before. We have those that you can supply, backslash filters that we can wash out the dirt. And if you have a marine environment with shells and so on, also a backflushing valve. Also these backflush the plate heat exchanger itself. So these are available for such duties. Sometimes also you need a good chemical resistance, and we have various materials. So for seawater, for example, we use titanium, and for the reservoir heating source. We also take this to the next level when it comes to sustainability by assuring that our material becomes carbon neutral, and our target is 2030 to have fossil-free steel supplied. We call it Concept Zero. In the meantime, we are increasing the recyclable part of materials, and now we are at 40% for our supply of the steel in our frames. Okay, so now I've been talking about how good this is and how sustainable it can be, but have we done this in, how much are we involved? Yes, we are involved in many heat pumps that has been installed, and they are increasingly installed for this capacity in the last 5 years. We have, for example, a couple of cases I can show here. This is a greenhouse heating in UK. 20 hectare of sustainable greenhouses. It's situated quite far out on the countryside, so they are running a CHP plant for making the power, but they can reduce here the carbon footprint by having in heat pumps, recovering heat from the discharge of the irrigation water, which they collect in ponds. And by that, with this 33 megawatt heat pump that we have supplied condensers, evaporators, and products, we are delivering 65,000 megawatt hours of thermal heating. COP 4.4, reducing the 12,600 tons of CO2 emissions annually. This could be higher if the power of the plant would be fossil-free electricity, of course. But this is where they are now, and that's got them a reward for renewable heat incentive in UK. Now coming to two cases in Denmark, and here is in Odense where they have using a sewage water, and that's a very good heat source that can be used in more places. So before the sewage water is relieved to the river, you take the heat from there, and then also the temperature of the water comes closer to the river water, which is good for the aquatic life, in the winter especially. And but this also, we can recover, like here, 60,000 megawatt hours of heat. COP is 4 here. This could probably be higher, but what we have here is that we have a secondary loop system with extra heat exchangers to protect the heat pump from dirt from the clean sewage water. But anyhow, 4 is quite nice, and we're reducing 128,000 tons of CO2 emissions over 5 years. So, okay, this is quite a lot. And yeah, so that's in practical has been running since 20 years. So, yeah. And then the data center is another heat source, and this is part of a bigger investment that a large social media giant invested. They could be connected to a district heating grid. Much due to this, sector coupling was possible by being quite close to a district heating grid. This is not always the case, but if you can do that, it's maybe something to think about for city planners. You can here recover heat from the cooling water of the data center and recover 100,000 megawatt hours of energy per year to warm some 7,000 homes and reduce CO2 emissions for these houses by 90%. That was previously heated by coal-fired power plants. So, yeah, here we have been supplying the evaporators condensers. So, plant is running also 5 years. So, yeah, this was what I wanted to present, and we are here and we are ready to discuss with you. We see ourselves as a leader in heat transfer with sustainable solutions, and we are available all around the world. So, looking at life cycle, and we would really appreciate partnership. We can also work globally. So, if some of you are from other continents, we are available as well there. And we have a booth. Come and see us in Hall 6, booth 138. T21 BW is there. And also we have smaller brazed evaporators and condensers for propane, specifically designed for that. And also some CO2 products, but this is what is new on the exhibition today. Thank you very much. Any